Good evening, guys. So today I'm going to talk to you about one of the more trickier things in the AS computer science spec. So we're going to look at Boolean algebra and we're going to look at logic gates. So moving on, what we're going to need to be able to do is define problems using Boolean logic. We're going to need to manipulate Boolean expressions and we're going to use logic gate diagrams and truth tables. Now, the latter C is actually quite simple to do when you get your head around uh, the way that we access our brackets, but after that it can get a bit more complicated. So we're going to start off by introducing you some simple logic gates and truth tables, and then we're going to move on from there. Now, obviously, in my lessons, we will be using a number of worksheets to help you piece some logic gates together. So logic gates we generally use to communicate data, and they are usually working with transistors inside the CPU to make the decision about what's happening. And the four that we're going to look at today are the AND, OR, NOT, and exclusive OR. And we're going to look at what happens when we input a value and what changes. So this is a simple AND gate. Now, just so you have a good idea of how to remember this type of gate, an AND gate needs both the inputs to be true in order for the output to be true, which you can see here. So A is 1 and B is 1. Now, I usually remember this by thinking, well, the gate looks like it has a D on the end of it. So that is how I remember it. So the last letter of AND is a D, which is what this gate looks like. Now the Boolean algebra symbol that you will need to know for this, so AND goes up. And the way that you can help remember that is a capital A. It looks like a capital A. So I hope that is useful in helping you to remember it. Then we have OR, which goes down. So remember, AND is like a capital A, or points down. Now the OR gate, either switch can be true. And I kind of help my students remember this by saying it looks a bit like a spaceship, or if you're a bit of a Trekkie or you like Star Trek, it looks like the badge that they used to wear. So that's kind of how I help them remember that. So this is an OR gate, and either switch must be true for the output to be true. Then we have a NOT gate, and a NOT gate, we have this little symbol here, which you will find underneath escape in case you've ever wondered what it was for. And that is this symbol for a NOT gate. And basically what a NOT gate does is it inverts your signal. So if you put a 1 into a NOT gate, the output will be false. So if the input is true, the output is false. And always remember to put this little dot on the end, because a lot of people forget that. Then we have exclusive OR. This looks like a plus symbol on your logic circuits. So what we've got here is exclusive OR, and it basically means that both of your inputs, either of your inputs can be true, okay, but you can't have both of them on. So you are exclusive to one or the other. So just bear that in mind. You are exclusive to having only one of the switches on. Moving on. So, in the lesson, I will have got you to actually try and combine a number of circuits there. So look back over your worksheets in the lesson and hopefully they'll help you understand how to draw them, and also if you look at the truth tables you'll be able to see how to combine those. Now moving to algebra, I've got this equation here, and if you remember this represents R equals not A or B. Okay, remember it doesn't look like a capital A, so it's not A or B, and we can make a truth table. So what we have here is I've got my inputs, A and B, and then what I've done is I put another column in to represent the value of not A. So I've done that, not A, so our input was off, so the signal was inverted, and we've got that there. So now I've got to do not A or B. So an OR gate, remember, one switch can be on. So A was on in this case, so the output was on. A or B, so the output is on. Neither of the signals were true in this case, so the output is off. And in this case, B was true, so the output was true. So I hope that makes a bit more sense. Replay it. Moving on to the next one. So this one has 3 inputs, so it's slightly more trickier. So we're going to work on our brackets first. So we've got A or B. Remember, this symbol means or not C. So we've got A or B. So we work that bit out first. Then we use the output from that to work out not C. So let's have a look. Now, before we have a look, we're going to look at the number of inputs. So to help you make a truth table, remember, if you have 2 inputs, then the outcomes, you usually have 4. If you have 3, you usually have 8. If you have 4, you usually have 16. And you'll see what I mean when I show you this. So I have, if you look, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 possible scenarios there. So the first thing I need to work out is A or B. So A or B was 0. A or B was 0. A or B, in this case, one switch was on the third column, so therefore it was 1, 1, 1, and so on. Then you work out what not C is. So in this case, 0 became 1. 1 became 0. 0 became 1, and so on. Now you've got those 2, now that you've separated that into 2, you've got the outcomes to do an OR gate with. So remember, 0 or 1 is 1. 0 or 0 is a 0. 1 or 1, because either switch is true, the output is 1. And so on. And you can see that as you go down the table. So that is how you create a truth table to represent that. What I would like you to do is try and convert these formulas to the symbols that you've seen, so that when you sit your exam, you can recognize them instantly. So we've got a not R and S and T, R and S and T, not R or S and T, R and S and not T. You might want to pause the video now, give it a go, see how you get on, and I will reveal the answers on the next slide. So now that you've done that, try and create a truth table to actually match your answers. See how you get on. There's an extension to try drawing some logic circuits, so see how you get on with that. I hope that this part 1 in a series of 2 videos is useful and helps you to kind of understand how the algebra is starting and how to work out your truth table. The next video will introduce Carnot maps, and they are slightly more complicated, but once you understand the patterns and learn how to read them, you should be able to see the algebra and how to simplify. Thank you for watching, and see you soon.